In this question, we're given a scatter graph, which shows information about the volume of traffic and the carbon monoxide level at a point on the road each day for 22 days. We're told that one point is an outlier, and in part A, we need to write down the coordinates of this point. Now the first thing that we can do is to define what an outlier is. And so we can say that an outlier is a point that lies outside of the overall pattern in a set of data. And so if we take a look at our scatter graph, we can see that there is a clear outlier in the top left corner. We can see that this point doesn't really fit in with the rest of the points, and it just kind of exists on its own. And so that's exactly what an outlier is. So we need to write down the coordinates of this point, and reading off our graph, we can see that the coordinates of this outlier is 118. Now we're then told that for another day, 370 cars pass the point on this road. And in part B, we need to estimate the carbon monoxide level for this day. And so we need to use our graph in order to find the carbon monoxide level at the point at which the number of cars is equal to 370. But before we can read that off our graph, we need to draw a line of best fit. Now that we've drawn our line of best fit, we can use this in order to find the carbon monoxide level on the day at which 370 cars pass the point on the road. To do this, we can start by identifying the point at which x is equal to 370 and drawing a vertical line from this point up until the line of best fit. And so you can see that we've identified the point at which the number of cars is equal to 370 and we've drawn a line up until the line of best fit. This is going to help us to find the carbon monoxide level at this day. We can now draw a horizontal line from the point at which the line of best fit and the purple line meet up until the y-axis. And so the point at which the horizontal line crosses the y-axis will tell us the carbon monoxide level at the point at which the number of cars is equal to 370. And so reading off from our graph, we can see that the purple horizontal line crosses the y-axis at the point at which the carbon monoxide level is equal to 13.6. And so our estimation for the carbon monoxide level for the day at which 370 cars pass the point on the road is equal to 13.6 milligrams per meters cubed. Now Alfie says that because there is an outlier, there is no correlation. And in part C, we need to decide if Alfie is correct, giving a reason for our answer. Now if we take another look at our graph, we can see that regardless of the outlier, the data still shows a positive correlation. And so the outlier doesn't affect correlation at all, because the outlier is a point that we can just ignore. And so we can say that Alfie is not correct, because we can ignore the outlier. Now this question is worth 4 marks. We get the first mark for the correct coordinates of the point of the outlier in part A. We get the second mark for drawing a line of best fit, so that we're able to estimate the carbon monoxide level on the day at which 370 cars pass the point on the road. And we get the third mark for using this line of best fit in order to find that the carbon monoxide level on this day was about 13.6 milligrams per meters cubed. And we get the fourth and final mark in part C for saying that Alfie is not correct because we can ignore the outlier, allowing us to achieve the full 4 marks needed in this question. In this question, we're told that Natalie makes potato cakes in a restaurant. She mixes potato, cheese and onion so that the ratio of the weight of potato to the weight of cheese to the weight of onion is equal to 9 to 2 to 1. We're told that she needs to make 6,000 grams of potato cakes. And we're also told that cheese costs £2.25 for 175 grams. We need to work out the cost of the cheese needed to make 6,000 grams of potato cakes. And so the first thing that we can do in this question is to start by finding the amount of cheese that she needs in order to make 6,000 grams of potato cakes. We know that the ratio of the weight of the potato to the weight of the cheese to the weight of the onion is equal to 9 to 2 to 1. And so this ratio has 12 parts in total, because 9 plus 2 plus 1 is equal to 12. Now since we want 6,000 grams of potato cakes in total, we can say that the total of 12 parts corresponds to 6,000 grams. Now if we know that 12 parts is equal to 6,000 grams, we can find the value of 1 part by dividing both sides by 12. 12 divided by 12 is equal to 1, and 6,000 divided by 12 is equal to 500. And so we can say that 1 part is worth 500 grams. But now we need to find the amount of cheese that's needed for 6,000 grams of potato cakes. We can see from our ratio that cheese corresponds to 2 parts of the ratio. And so we can say that the amount of cheese needed is equal to 2 parts, and if 1 part is equal to 500 grams, 2 parts would be equal to 1000 grams. And so we can say that we need 1000 grams of cheese in order to make 6000 grams of potato cakes. But now we need to find the cost of the cheese needed to make 6000 grams of potato cakes, and so we need to find the cost of 1000 grams of cheese. We know that 175 grams costs £2.25. And so in order to find the cost of 1000 grams of cheese, we can multiply both sides by the fraction 1000 over 175. Now 175 multiplied by 1000 over 175 is equal to 1000 grams, and £2.25 multiplied by 1000 over 175 is equal to £12.86. And so we've found that the cost of 1000 grams of cheese is equal to £12.86, and therefore the cost of the cheese needed to make 6000 grams of potato cakes is equal to £12.86. Now this question is worth 4 marks. We get the first mark for stating that the ratio has a total of 12 parts. We get the second mark for using this ratio in order to find that the amount of cheese needed to make 6000 grams of potato cakes is equal to 1000 grams. We get the third mark for our process to find the cost of 1000 grams of cheese by multiplying £2.25 by 1000 over 175. And we get the fourth mark for our correct final answer that the cost of cheese needed to make 6000 grams of potato cakes is equal to £12.86. Allowing us to get the full 4 marks needed in this question. In part A, we need to write 4.5 times 10 to the power of 5 as an ordinary number. Now we know that 10 to the power of 5 is equal to 100,000, and so this is equivalent to 4.5 multiplied by 100,000, which is equal to 450,000. Now in part B, we need to write 0.007 in standard form. Now remember, in standard form, we need to have a number between 1 and 10, and then we have times 10 to any power. Now the number between 1 and 10 in this case would be equal to 7. And so 7 times 10 to the power of something is equal to 0.007. Now because this is a decimal number, we can think of this as division. 7 divided by 1000 is equal to 0.007. But now we can say that divided by 1000 is equivalent to multiplying by 10 to the power of minus 3. And so 0.007 is equivalent to 7 times 10 to the minus 3 in standard form. Now finally in part C, we need to work out 4.2 times 10 to the power of 3 plus 5.3 times 10 to the power of 2, giving our answer in standard form. Now one way to think of this could be algebra. We can imagine that 10 to the power of 3 is equal to A, and 10 to the power of 2 is equal to B. Now if you had the equation 4.2a plus 5.3b, we can't actually simplify this because a and b are different terms. And so now the only way to simplify this is to make the power of 10s equal so that they're the same term. For example, we can say that 5.3 times 10 to the power of 2 is equivalent to 0.53 times 10 to the power of 3. We said that 10 to the power of 3 could be equal to a, and so that would be the same as 4.2a plus 0.53a. And you can see that now that both numbers have the same power of 10, we can add them as though they're normal algebra, because they're like terms. And so our original expression can be written as 4.2 times 10 to the power of 3 plus 0.53 times 10 to the power of 3. And now since we have the same power of 10, we can add them up as normal. 4.2 plus 0.53 is equal to 4.73. And so we can say that 4.2 times 10 to the power of 3 plus 0.53 times 10 to the power of 3 is equal to 4.73 times 10 to the power of 3. Now this question is worth 4 marks. We get the first mark in part A for saying that 4.5 times 10 to the power of 5 is equivalent to 450,000. We get the second mark in part B for saying that 0.007 in standard form is equivalent to 7 times 10 to the power of minus 3. We get the third mark for saying that 5.3 times 10 to the power of 2 is equivalent to 0.53 times 10 to the power of 3. And we get the fourth and final mark for the correct answer of part C and for saying that 4.2 times 10 to the power of 3 plus 5.3 times 10 to the power of 2 is equivalent to 4.73 times 10 to the power of 3, allowing us to get the full 4 marks needed in this question. In this question, we're told that a water tank is empty, and Anil needs to fill the tank with 2,400 litres of water. We're told that Company A supplies water at a rate of 8 litres in 1 minute and 40 seconds, and Company B supplies water at a rate of 2.2 gallons per minute. We're then told that 1 gallon is equivalent to 4.54 litres. Company A would take more time to fill the tank than Company B would take to fill the tank, and we need to find out how much more time Company A would take, giving our answer in minutes, correct to the nearest minutes. Now we can start by finding the amount of time that Company A would take, and then we can find the amount of time that Company B would take, and then compare the two times. Let's start with Company A. Company A supplies water at a rate of 8 litres in 1 minute and 40 seconds. Now we want to convert 1 minute 40 seconds into minutes. 1 minute plus 40 seconds is equivalent to 1 minute plus 40 out of 60 minutes, because we have 40 seconds out of a total of 60 seconds in 1 minute. Now 1 plus 40 over 60 is equivalent to 1 plus 2 over 3, which is equal to 5 over 3. And so 1 minute and 40 seconds is equal to 5 over 3 minutes. Now we can find out how long Company A takes to fill the tank with 2,400 litres of water. We know that it takes 5 out of 3 minutes to fill the company with 8 litres of water. And so to find the time it takes to fill the tank with 2,400 litres of water, we can multiply both sides by 300. 8 times 300 is equal to 2,400. And 5 over 3 multiplied by 2,400 is equal to 500. And so we've now found that Company A will take 500 minutes in order to fill the tank with 2,400 litres of water. Now let's work out how long Company B takes. We're told that Company B supplies water at a rate of 2.2 gallons per minute. Let's start by converting 2.2 gallons into litres. We know that 1 gallon is equal to 4.54 litres, and so to find 2.2 gallons, we can multiply both sides by 2.2. 1 multiplied by 2.2 is equal to 2.2, and 4.54 multiplied by 2.2 is equal to 9.988. And so we can say that 2.2 gallons is equivalent to 9.988 litres. Now if we know that Company B supplies 2.2 gallons in a minute, we can say that this is equivalent to 9.988 litres in 1 minute. We want to find how long it takes to fill the tank with 2,400 litres, and so we can multiply both sides by 2,400 over 9.988. 9.988 multiplied by 2,400 over 9.988 is equivalent to 2,400 litres, and 1 multiplied by this fraction is approximately 240. And so we've found that Company B takes approximately 240 minutes in order to fill the tank with 2,400 litres of water. Now remember that in this question, we need to find out how much more time Company A would take compared with Company B. And so essentially what we're asked to do is to find the difference between the amount of time Company A takes and the amount of time Company B takes. The difference would be equal to 500 take away 240, which is equal to 260. And so we can therefore say that Company A takes 260 minutes longer than Company B. Now this question is worth 4 marks. We get the first mark for converting some quantities into more common units. For example, for saying that 1 minute and 40 seconds is equivalent to 5 over 3 minutes, and for saying that 2.2 gallons is equivalent to 9.988 litres. We get the second mark for finding that Company A takes 500 minutes to fill the tank. We get the third mark for finding that Company B takes around 240 minutes to fill the tank. And we get the fourth mark for finding the difference between the two times, and for therefore concluding that Company A takes 260 minutes longer than Company B, allowing us to get the full 4 marks needed in this question. In this question, we're told that the first 4 terms of a Fibonacci sequence are A, 2A, 3A, and 5A. We're then told that the sum of the first 5 terms of the sequence is equal to 228, and we need to work out the value of A. Let's first start by defining what a Fibonacci sequence is. Now a Fibonacci sequence is one where each number in the sequence is the sum of the two numbers that came before it. For example, if we see the third term, we can see that it's the sum of the first term and the second term, because a plus 2a is equal to 3a. And if we look at the fourth term, we can see that it's the sum of the two numbers before it, because 2a plus 3a is equal to 5a. And so we can use this definition of a Fibonacci sequence in order to find the fifth term of the sequence. But now since we said that a Fibonacci sequence is one where each number is the sum of the two numbers that come before it, we can say that the fifth term must be equal to the third term plus the fourth term. We can see that third and fourth terms are 3a and 5a, and so the fifth term must be equal to 3a plus 5a, which is equal to 8a. And so we've found that the fifth term is equal to 8a. Now we're told that the sum of the first 5 terms in the sequence is equal to 228. The sum of the first 5 terms would be equal to a plus 2a plus 3a plus 5a plus 8a. And we can say that this is all equal to 228. Now we can simplify this because a plus 2a plus 3a plus 5a plus 8a is equivalent to 19a. And so we can say that 19a is equal to 228. To find the value of a, we can divide both sides by 19. 19a divided by 19 is equal to a, and 228 divided by 19 is equal to 12. And so we've found that the value of a is equal to 12. Now this question is worth 3 marks. We get the first mark for finding that the fifth term of the sequence is equal to 8a. We get the second mark for setting up the equation a plus 2a plus 3a plus 5a plus 8a is equal to 228. And we get a third and final mark for simplifying and rearranging in order to find that the value of a is equal to 12, allowing us to achieve the full 3 marks needed in this question. In this question, we're told that in a bag there are only red counters, blue counters, green counters, and pink counters. A counter is going to be taken at random from the bag. Now the table below shows the probabilities of taking a red counter or a blue counter. We're also told that the probability of taking a green counter is 0.2 more than the probability of taking a pink counter. And in part A, we need to complete the table of probabilities. Now the first thing that we can identify is the fact that all of the probabilities must add up to 1, which means that the probability of red plus the probability of blue plus the probability of green plus the probability of pink should all equal to 1. And so using this fact, we can say that the probability of green plus the probability of pink is 1 take away these two probabilities. And so 0.05 plus 0.15 is equal to 0.2, and 1 take away 0.2 is equal to 0.8. And so the probability of green plus the probability of pink is equal to 0.8. We're told that the probability of taking a green counter is 0.2 more than the probability of taking a pink counter. And so we can say that the probability of taking a pink counter is equal to x, and the probability of taking a green counter is equal to x plus 0.2. Now we know that the probability of pink plus the probability of green need to add up to 0.8, and so we can say that x plus 0.2 plus x is equal to 0.8. Simplifying this, we can say that 2x plus 0.2 is equal to 0.8. Moving the 0.2 over to the other side, we can say that 2x is equal to 0.6, and therefore, dividing both sides by 2, x is equal to 0.3. Now if x is equal to 0.3, we can say that the probability of taking a pink counter is 0.3. And since the probability of green is x plus 0.2, the probability of taking a green counter is equal to 0.3 plus 0.2, which is equal to 0.5. And so we've now completed the table by finding that the probability of taking a green counter is 0.5, and the probability of taking a pink counter is 0.3. Now in part B, we're told that there are 18 blue counters in the bag, and we need to work out the total number of counters in the bag. Now we know that the probability of taking a blue counter is 0.15. Now 0.15 corresponds to 15%, and so we can say that 15% of the counters are blue. Now if there are 18 blue counters in the bag, that means that 15% is equal to 18. And now since we're interested in finding the total number of counters in the bag, we want to find 100%. Now if we know that 15% is equal to 18, we can start by finding 1% by dividing both sides by 15. 15% divided by 15 is equal to 1%, and 18 divided by 15 is 1.2. And so we found that 1% of the total number of counters in the bag is equivalent to 1.2. Now to find 100%, we can multiply both sides by 100. 1% multiplied by 100 is equal to 100%, and 1.2 multiplied by 100 is 120. And so we found that the total number of counters in the bag is equal to 120. Now this question is worth 4 marks. We get the first mark in part A for finding that the probability of green is 0.5, and the second mark in part A for finding that the probability of pink is 0.3. We get the third mark in part B for using the fact that 15% is equal to 18 for a process to find 100%. And we get the fourth mark for the correct final answer that the total number of counters in the bag is equal to 120, allowing us to get the full 4 marks needed in this question. In this question, we're given a diagram which shows a sector OPQR of a circle with centre O and radius 8 cm. We're then told that OPR is a triangle, and we need to work out the area of the shaded segments PQR, giving our answer correct to 3 significant figures. Now we can identify that the area of the shaded segment PQR is equal to the total area of the sector, take away the area of the triangle. And just to clarify, the sector would be the entire shape OPQR, and the triangle would be the region in white. Now we know that the area of a sector is given by the formula theta over 360 multiplied by pi r squared, where theta is the angle of the sector. Now in our situation, we have a right angle, and so we can say that theta is equal to 90 degrees. And so let's substitute in our values for the area of the sector. We said that theta is equal to 90, and we know that the radius is equal to 8, and so pi r squared becomes pi multiplied by 8 squared. Now we know that 8 squared is equal to 64, and 90 over 360 can be simplified to 1/4. And so 1/4 multiplied by pi multiplied by 64 is equal to 16 pi. And so for now, it's easier to leave our answer in terms of pi, and then we can round at the very end. Well, now that we found the area of the sector, we can find the area of the triangle OPR. We know that the formula for the area of a triangle is equal to the base multiplied by the height, all divided by 2. We have a base of 8 cm and a height of 8 cm, and so base times height divided by 2 is equal to 8 times 8, all divided by 2, which is equal to 32. Now we said that the area of the shaded segment PQR is equal to the area of the sector, take away the area of the triangle, which in this case is equal to 16 pi, take away 32. And when we put that into our calculator, we'll find that the area of the shaded segment PQR is equal to 18.26548 ... which rounds to 18.3 cm squared to 3 significant figures. And so we found that the area of the shaded segment PQR is equal to 18.3 cm squared. Now this question is worth 4 marks. We get the first mark for finding that the area of the sector is equal to 16 pi. We get the second mark for finding that the area of the triangle is equal to 32. We get the third mark for a process to find the area of the shaded segment PQR by doing the area of the sector, take away the area of the triangle. And we get the fourth and final mark for the correct answer that the area of the shaded segments PQR is equal to 18.3 cm squared, rounded to 3 significant figures, allowing us to get the full 4 marks needed in this question. In this question, we're given 2 sets of axes, and in part A, we need to sketch a graph to represent the statement y is directly proportional to x. Now if y is directly proportional to x, we know that y is equal to kx, where k is a constant. And so using our knowledge of linear equations, the graph of y equals kx is a straight line graph that has no y-intercept, and so it goes straight through the origin. And so if y is directly proportional to x, we have a straight line that goes through the origin. Now in part B, we need to sketch a graph to represent the statements y is inversely proportional to x. Now if y is inversely proportional to x, we can say that y is equal to k over x, where k is just a constant. And so the graph of y equals k over x will look something like this. If you haven't seen something like this before, that's fine. You just need to make sure that you familiarise yourself with the graph of y equals k over x and the graph of y equals minus k over x. but for now, we've drawn the graph of y equals k over x. Now this question is worth 2 marks. We get the first mark in part A for correctly sketching a graph to represent the statements y equals kx, which is a straight line graph through the origin. And we get the second mark in part B for sketching a graph which represents the statements y is inversely proportional to x. And so we've now achieved the full 2 marks needed in this question. In this question, we're told that on Monday, 12 people took 5 hours to clean a number of cars. And on Tuesday, 15 people cleaned the same number of cars. Now, assuming that all of the people worked at the same rate, in part A, we need to work out how many hours the 15 people took to clean the cars. Now, a very easy mistake to make here is not recognising the inverse proportion. And so what this means is that more people cleaning means that less time is taken to clean the cars. And so you can see that there's an inverse proportion in the sense that as one variable goes up, the other variable goes down. As the number of people goes up, the time taken goes down. And so let's see what this means when we apply this to our question. If 12 people took 5 hours to clean the cars, we want to find out how long it would take 15 people to clean the cars. Well, let's start by finding how long it takes one person to clean the cars. Now, to get from 12 people to 1 person, we divide by 12. But now, because there's an inverse proportionality here, if we divide on the left-hand side, we have to multiply on the right-hand side. And so we divided by 12 on the left-hand side, which means that we'll multiply by 12 on the right-hand side. 5 times 12 is 60, and so we can say that 1 person would take 60 hours to clean all of the cars. Well, now let's use the same logic to find the amount of time that 15 people would take to clean the cars. Now, to get from 1 to 15, we multiply by 15. And so whatever we do on the left-hand side, we have to do the opposite on the right-hand side. On the left-hand side, we multiply by 15, and so on the right-hand side, we need to divide by 15. 60 divided by 15 is equal to 4. And so we can say that 15 people would take 4 hours to clean the cars. Now in part B, we're told that the assumption is wrong, and we need to explain how this might affect the time taken for the 15 people to clean the cars. Now the original assumption was that all of the people worked at the same rate. Now if this assumption is wrong, it could take more time to clean the cars, or it could take less time to clean the cars, and we're not given enough information to figure out whether it would be more or less. And so that's all we need to write. We just need to say that it could take either more time or less time for the 15 people to clean the cars. And so our answer to part B is that it could take more or less time for the 15 people to clean the cars. Now this question is worth 3 marks. We get the first mark in part A for finding that 1 person would take 60 hours to clean the cars. And we get the second mark in part A for using this in order to find that 15 people would take 4 hours to clean the cars. And we get the third and final mark in part B for saying that it could take more or less time if the assumption is wrong, allowing us to get the full 3 marks needed in this question. In this question, we're given a diagram which shows 2 right-angled triangles, ACB and DEB. We're told that the length of AD is equal to 9 cm, the length of DE is equal to 2 cm, and the length of DB is equal to 6 cm. We need to calculate the length of the line CB, giving our answer correct to 2 decimal places. Now we can label the information that was given to us on our diagram. We've been asked to calculate the length of CB, and we need to think, how might we do that? Well, let's think about what we've been given in our question. We have 2 right-angled triangles, and so when you see right-angled triangles, the first few things that might come to mind would be Pythagoras' theorem or trigonometry. And so it's likely that we might use one of those. But notice here that we have 2 triangles, and when we have 2 triangles and we're given information about both of them, we might be talking about similar triangles or congruent triangles, or some relationship between the 2 triangles that will help us find out more information. Now we can draw both of these triangles separately in order to help us understand. You can see here that we have triangle ABC and we have triangle DEB. We can also see that this angle over here would be the same in triangle ACB and the same in triangle DEB. Now we can see that both of these triangles have identical interior angles, but they have different sides. Now using this information, we can see that these 2 triangles are similar. And so similar triangles are triangles that have the exact same shape, but they might have different sizes. For example, the length of the sides may be different. But now for them to be exactly the same shape, all the length must be in proportion. What this means is that there's a scale factor. If we multiply the length of one side, we need to multiply the length of every other side by the exact same scale factor. So if the length of AC, for example, was 4, that means we multiplied this by 2. And so that means the length of AB would have to be 6 times 2, which is equal to 12. Well, now that we understand the concept, let's think about how we might find the length CB. The first thing that we need to do is to find the actual scale factor between the two triangles. But right now we don't have any lengths in this triangle, and we need at least one length from both triangles in order to find a scale factor. But we can find out the length AB, because if we look at the original diagram, we can see that the length of AB is equal to 9 plus 6, which is equal to 15. Now we have the length of a side on triangle DBE, and we have the length of the same side on triangle ABC. Let's use this to find the scale factor. We can say that 6 multiplied by the scale factor is equal to 15. And dividing both sides by 6, we can say that the scale factor is equal to 15 divided by 6, which is equal to 2.5. Now we've found a scale factor of 2.5. Our final answer should be the length of line CB. Now we can see that the line CB is the corresponding length of the line EB, and if we know EB, we can multiply EB by the scale factor in order to find CB. We have enough information to find EB using Pythagoras' theorem, like we said before. We know that a squared plus b squared is equal to c squared, and c is always equal to the length of the hypotenuse. We can say that 2 squared plus be squared is equal to 6 squared. And so the length of line BE would be equal to the square root of 6 squared take away 2 squared, which when we put into our calculator, we'll find that the length of BE is equal to root 32. Now that we know the length of line BE, we said that we can find the length of line CB using the scale factor. If BE is equal to root 32 centimeters and the scale factor is equal to 2.5, we can say that the length of CB is equal to root 32 multiplied by 2.5. And when we put that into our calculator, we'll find that the length of CB is equal to 14.14 centimeters to 2 decimal places. And so we've now found that the length of CB is equal to 14.14 centimeters. Now this question is worth 4 marks. We get the first mark for finding that the scale factor is equal to 2.5. We get the second mark for finding that the length of line BE is equal to root 32. We get the third mark for the correct process to find the length of CB by doing root 32 multiplied by the scale factor of 2.5. And we get the fourth mark for the correct final answer that the length of line CB is equal to 14.14 centimeters to 2 decimal places, allowing us to get the full 4 marks needed in this question. In this question, Freya writes down the value of x, correct to 1 decimal place. She writes that x is equal to 6.4, and we need to complete the error interval for x. Now to find the error interval, we're going to use place value, and so we can write 6.4 with a bunch of zeros before the 6 and after the 4. All of these zeros exist, but we just don't write them down. And so using our knowledge of place value, we can see that 6 would be the units. If there was a number here, for example, it would be the tens, over here it would be the 100s, and so on. And now as for the number 4, we can see that its place value is 1/10th. The next zero would be 100th, the next one would be 1000th, and so on. But we just need to focus on the numbers that we have. We have 6 and 4. We said that 6 is a unit, and 4 is a tenth. Now to find the error interval, we need to use the value that it was rounded to. We're told that Freya writes down the value of x correct to 1 decimal place. And so to find the error interval, we need the place value of 1 decimal place. Now 1 decimal place would be this number over here, because 4 has been rounded to 1 decimal place. We can see that the place value of the number 4 is equal to 1/10th. And so 1 decimal place is equal to 1/10th, which is equal to 0.1. To find the error interval for x, we need to find half of the place value. We said that the place value is equal to 0.1, and so half of 0.1 would be equal to 0.05. And so because we've rounded to 1 decimal place, the error interval would be 0.05 on either side of x. X is equal to 6.4. And now if the error interval is 0.05 on either side, we'll have 6.4 take away 0.05 on the left-hand side, and 6.4 add 0.05 on the right-hand side. 6.4 take away 0.05 is equal to 6.35, and 6.4 plus 0.05 is equal to 6.45. And so our error interval for the value of x would be 6.35 is less than or equal to x, and x is less than 6.45, which we've shown over here. And so we've now correctly written down the error interval for x. Now this question is worth 2 marks. We get the first mark for correctly writing 6.35 on the left-hand side, and we get the second mark for correctly writing 6.45 on the right-hand side, allowing us to get the full 2 marks needed in this question. In this question, we're told that ax to the power of 6, all to the power of 1 over n, is equal to 7x cubed. We need to work out the value of a and the value of n. Now to answer this question, we're going to use 2 very important index laws. The first one is that x to the power of a, all to the power of b, is equivalent to x to the power of a multiplied by b. For example, x to the power of 2, all to the power of 3, is the same as x to the power of 2 times 3, which is equal to x to the power of 6. Now the next rule is that xy, all to the power of a, is equivalent to x to the power of a multiplied by y to the power of a. For example, if we had xy, all to the power of 2, that's the same as saying x to the power of 2 multiplied by y to the power of 2. Well, now that we understand those, let's work out the value of a and the value of n. We know that ax to the power of 6, all to the power of 1 over n, is equal to 7x cubed. Well, now we need to use the second rule, because we have ax to the power of 6, all to the power of 1 over n, and so using the second rule, we can say that that's equivalent to a to the power of 1 over n multiplied by x to the power of 6 to the power of 1 over n. And so we can say that this is equal to 7x cubed. Well, now we can use the first rule. We said that x to the power of a, all to the power of b, is equal to x to the power of a times b. We can use that in this case. We have x to the power of 6, all to the power of 1 over n, and so that's equivalent to x to the power of 6 times 1 over n, which is the same as x to the power of 6 over n. And so over here we have the a to the power of 1 over n multiplied by x to the power of 6 over n is equal to 7x cubed. Now let's take a look at these arrows. We can say that a to the power of 1 over n corresponds to the coefficient of 7, and x to the power of 6 over n corresponds to x to the power of 3. And so since they must be equal, we can say that a to the power of 1 over n is equal to 7, and x to the power of 6 over n is equal to x cubed. So now we can see if this has given us enough information in order to find out the value of a and the value of n. We'll start by finding the value of n. We said that x to the power of 6 over n is equal to x to the power of 3. And so based on this, we can say that 6 over n is equal to 3. Now rearranging, we can say that n is equal to 6 divided by 3, which is equal to 2. Now we can find the value of a. We said that a to the power of 1 over n is equal to 7. Well, we know that n is equal to 2, and so a to the power of 1 over 2 is equal to 7. A to the power of 1/2 is equivalent to the square root of a, and so we can say that the square root of a is equal to 7. We can now square both sides and say that a is equal to 7 squared, which is equal to 49. And so we've now found that the value of a is equal to 49, and the value of n is equal to 2. Now this question is worth 2 marks. We get the first mark for finding the correct value of a, and we get the second mark for finding the correct value of n, allowing us to get the full 2 marks needed in this question. In this question, we have a pattern that's made from 4 identical rectangles. The sides of the rectangles are parallel to the axes. We're told that point A has coordinates 3, 4, point B has coordinates 11, 20, and point C is marked on the diagram. We need to work out the coordinates of point C. Let's think of a way that we can look at this diagram to make it a little bit clearer. This new diagram is identical to the original diagram, but we've labelled in some measurements. We've assumed that the horizontal side has a length of x and the vertical side has a length of y, and since all 4 rectangles are identical, we can use this for each of the rectangles. We want to find the vertical length and the horizontal length. And so if B has coordinates 11, 20, we can see that the x coordinate of B would be 11 and the y coordinate of B would be 20. The same goes for point A, 3, 4. The x coordinate is 3 and the y coordinate is 4. Now to find the value of point C, let's start by finding the values of x and y. We can say that this vertical length here is equal to 20. And so let's see if we can create an expression with x and y based on this length. Now the vertical length of 20 would be equal to this length, plus the small length here, plus this length, plus this length. We know the length of each of these 4 parts, and so we can say that the vertical length would be equal to 4 plus y plus x, which is equal to the height of 20. We can do the same thing on the horizontal side. We have the horizontal length, which equals 11, and so let's see if we can break this down into parts that we already know the length of. The only part that needs a little bit more thinking would be this length over here. We know that this length x is the length of the horizontal side, and this length y is the length of the vertical side of this rectangle. And so the length that I'm circling right now would be x take away y. And so the horizontal length, which has a total of 11, can be broken down into this part, plus this part, plus this part. We know the length of all 3 parts, and so we can find an expression by saying that 3 plus x minus y are all equal to 11. Now we have 2 expressions that we can use in order to find the values of x and y, but let's simplify what we know already. We can start with the vertical length. 4 plus y plus x is equal to 20. We know that x plus x is equal to 2x, and so 4 plus y plus 2x is equal to 20. Now we can move the 4 over to the other side by subtracting 4 on each side, and so we end up with 2x plus y is equal to 16. Finally, we can end up with an expression for 2x by moving the y to the right hand side, and for therefore saying that 2x is equal to 16 take away y. Let's see if we can do the same thing for the horizontal length. We have 3 plus x minus y is equal to 11. Just as before, x plus x is equal to 2x, and so 3 plus 2x take away y is equal to 11. We can move the 3 to the right hand side by subtracting 3 from each side, and we end up with 2x take away y is equal to 8. And finally, to get an expression for 2x, we can move the y over to the right hand side, and we end up with 2x is equal to 8 plus y. Now you can see here that we have 2 sets of simultaneous equations. We have 2x is equal to 16 take away y, and 2x is equal to 8 plus y. In order to find the value of x and the value of y, we can set these up as equal to one another. And so 16 take away y would be equal to 8 plus y, because 2x is equal to 2x. And so we've written that over here. We can use this in order to find the value of y. And so over here, we've moved the minus y to the right hand side, and we've moved the 8 to the left hand side. And so we end up with 16 take away 8 is equal to y plus y, therefore 8 is equal to 2y. To find the value of y, we can divide both sides by 2, and we end up with y is equal to 4. Well, now that we know the value of y, we can substitute the value of y in to either of these equations in order to find the value of x. Let's use 2x equals 8 plus y. Since 2x is equal to 8 plus y, and y is equal to 4, we can say that 2x is equal to 8 plus 4, which is equal to 12. We now know that 2x equals 12, and so we can divide both sides by 2 in order to find the value of x, which leaves us with x is equal to 6. But now remember that we want to find the coordinates of point C, which is labelled here on our diagram. Let's think about how we might find the coordinates of C. we know the coordinates of point A, which is 3, 4. And to get from A to C, we move x spaces to the right and y spaces up. Now we know that the value of x is equal to 6, and the value of y is equal to 4. And so to find point C, we can use the coordinates of A. To move x to the right, we can add x to the x coordinate of 3, and to move y up, we can add y to the y coordinates of 4. And so you can see that the coordinates of point C would have an x coordinate of 3 plus x and a y coordinates of 4 plus y. 3 plus x is equal to 3 plus 6, which is equal to 9, and 4 plus y is 4 plus 4, which is equal to 8. And so we've found that the coordinates of point C are 9, 8. Now this question is worth 5 marks. We get the first mark for finding an expression for the height by saying that 2x is equal to 16 take away y. We get the second mark for doing the same thing for the width, and for saying that 2x is equal to 8 plus y. We get the third mark for finding that y is equal to 4 and x is equal to 6. We get the fourth mark for finding that the x-coordinate of point C is equal to 9, and we get the fifth and final mark for finding that the y-coordinate of point C is equal to 8. Allowing us to achieve the full 5 marks needed in this question. In this question, we're told that Olivia and Jessica have in total half as many sweets as Fran and Gary have in total. We're told that Fran and Gary share their sweets in the ratio 2 to 3, and that Olivia and Jessica share their sweets in the ratio 9 to 1. We're told that Fran got W sweets, Gary got X sweets, Olivia got Y sweets, and Jessica got Z sweets. And we need to find, in its simplest form, W to X to Y to Z. And so we can find out how many sweets that each person got. Let's start by adding some numbers to help make this a little bit clearer. If Olivia and Jessica have in total half as many sweets as Fran and Gary have in total, we can say that Olivia and Jessica have in total 50 sweets. And this is just any number that we can use, as long as it fits what the question is saying. Now if Olivia and Jessica have half as many sweets as Fran and Gary have, we can say that Fran and Gary have double what Olivia have, and so double 50 is equal to 100. And so we've said so far that Olivia and Jessica have 50 sweets, and Fran and Gary have 100 sweets. Now let's take a look at the ratios. We're told that Fran and Gary share their sweets in the ratio 2 to 3. Now 2 plus 3 is equal to 5, and so this ratio corresponds to 5 parts. We also said that Fran and Gary have in total 100 sweets, and so we can say that these 5 parts represent 100 sweets. We can find the value of 1 part, therefore, by dividing both sides by 5, and so 100 divided by 5 is equal to 20. 1 part is equal to 20 sweets. We know that Fran has 2 parts, and Gary has 3 parts, and so we can say that Fran has 2 times 20, which is equal to 40 sweets, and Gary has 3 times 20, which is equal to 60 sweets. And so we've found that Fran has 40 sweets and Gary has 60 sweets. We can do the exact same thing for Olivia and Jessica. Olivia and Jessica share their sweets in the ratio 9 to 1. We know that this corresponds to a total of 9 plus 1, which is equal to 10 parts. Now Olivia and Jessica have 50 sweets in total, and so these 10 parts correspond to 50 sweets. We can find the value of 1 part by dividing both sides by 10, and so 50 divided by 10 is equal to 5. 1 part represents 5 sweets. We know that Olivia gets 9 parts, and Jessica gets 1 part, and so Olivia will get 9 times 5 equals 45 sweets, and Jessica has 1 times 5 equals 5 sweets. Well, now remember that we need to find the ratio W to X to Y to Z. We know that Fran got W sweets, Gary got X sweets, Olivia got Y sweets, and Jessica got Z sweets. Like we said, Fran has 40 sweets, Gary has 60, Olivia has 45, and Jessica has 5. And so the ratio W to X to Y to Z would be equal to 40 to 60 to 45 to 5. But now this question asks us to give our ratio in its simplest form. And so we can divide each part by 5. 40 divided by 5 is equal to 8, 60 divided by 5 is 12, 45 divided by 5 is 9, and 5 divided by 5 is 1. And so in its simplest form, we found that the ratio w to x to y to z is equal to 8 to 12 to 9 to 1. And so we've now correctly found the ratio w to x to y to z in its simplest form. Now this question is worth 4 marks. We get the first mark for finding the number of sweets that Fran has and the number of sweets that Gary has. We get the second mark for finding the number of sweets that Olivia has and the number of sweets that Jessica has. We get the third mark for combining these ratios. And we get the fourth and final mark for simplifying this combined ratio into its simplest form, and we found that the ratio of w to x to y to z is equal to 8 to 12 to 9 to 1 in its simplest form, allowing us to get the full 4 marks needed in this question. In this question, we're given a graph which gives the volume of water in litres in a container at time t seconds after water started to flow out of the container. Using the graph, we need to work out an estimate for the rate at which the water is flowing out of the container when t is equal to 12. And now the first thing that we can always say is that when we have a graph with time on the x-axis, the rate is always equal to the gradient of the graph. This graph is a curve, and so when we want to find the gradient of a curve, we need to draw a tangent. Because we need to find the rate at the point at which t is equal to 12, we can draw a tangent when t is equal to 12. Now t is equal to 12 right here. And so we can draw a tangent at this point. Now we've drawn our tangent in purple, but you can also see a blue triangle. Now, to find the gradient of a line, what do we need to do? We need to find the change in y divided by the change in x. Now when we have a line, it's always good to draw a triangle. We can use our triangle to do this. For the vertical length, we have 24 at the top and 13 at the bottom. And so the change in y values would be 24 take away 13. And we can do the same thing for the change in x. On the horizontal side of our triangle, we have 15.5 at the end and 5 at the beginning. And so the change in x would be equal to 15.5 take away 5. And so plugging this entire fraction into our calculator, we can see that the gradient is approximately equal to 1.047 ... which we can round to 1.0 to two significant figures. And so we've found that an estimate for the rate at which the water is flowing out of the container when t is equal to 12 is approximately 1.0 litres per second. Now this question is worth 3 marks. We get the first mark for drawing a tangent at t is equal to 12. We get the second mark for our process to find the gradient of this tangent by doing the change in y divided by the change in x. And we get the third and final mark for the correct answer that the rate at which water is flowing out of the container when t is equal to 12 is approximately 1.0 litres per second, allowing us to get the full 3 marks needed in this question. Now in this question we have a curve C which has equation y equals x squared plus 3x minus 3. And then we have the line L which has equation y minus 5x plus 4 is equal to 0. We need to show algebraically that C and L have exactly 1 point in common. Now if they have 1 point in common, the y value for point C and the y value for point L will be equal, and the x value for point C and the x value for point L will also be equal. And so when we have to find 1 point in common, we need to solve the two equations as simultaneous equations, because x and y are equal for both equations. But now we need to prove that they have exactly 1 point in common. And so to prove that they have exactly 1 point in common, that means there's only one solution for x and one solution for y. When we solve these as simultaneous equations, we're going to end up with a quadratic. And most of the time when we have a quadratic equation, we end up with 2 solutions, 2 values of x and 2 values of y. And so to prove that they have exactly 1 point in common, we're going to need to end up with a quadratic expression that only has 1 value for x and 1 value for y. So let's begin to solve and see where we end up. We have C, which has equation y equals x squared plus 3x take away 3, and L, which has equation y minus 5x plus 4 is equal to 0. Now to solve them with simultaneous equations, we can make y the subject of both equations. For courtesy, y is already the subject, but for line L, we can make y the subject by moving the minus 5x to the right hand side and by moving the 4 to the other side, leaving us with y equals 5x take away 4. Now since x and y are both equal, we can say that y is equal to y, and so x squared plus 3x take away 3 is equal to 5x take away 4. We can move the 5x and the minus 4 all to the left hand side, because we want a quadratic equation with 0 on the right hand side, and so we end up with x squared plus 3x take away 5x minus 3 plus 4 is equal to 0. And so the minus 5x came from moving this to the right hand side, and the plus 4 came from moving the minus 4 to the other side. Now we can simplify by collecting like terms. X squared stays how it is. We then have 3x take away 5x, which is equal to minus 2x, and then we have minus 3 plus 4, which is equal to plus 1, which is all equal to 0. Now x squared minus 2x plus 1 is equal to 0, and so we can factorise in order to find the value of x. By factorising this, we end up with x minus 1 all squared is equal to 0, and so therefore x must be equal to 1. We found that x is equal to 1, but remember, like we said, that in most quadratic expressions we end up with two values for x. We can see that in this situation we have x minus 1 all squared, which means that there's only one solution for x, and x is equal to 1. And so automatically this proves that C and L have exactly 1 point in common. And we have to have a conclusive statement at the end to explain this. We can say that there is only one value of x, and so C and L have exactly 1 point in common. And so we've now proven algebraically that C and L have exactly 1 point in common by finding that there's only one value of x when we solve the simultaneous equations. Now this question is worth 4 marks. We get the first mark for setting x squared plus 3x minus 3 equal to 5x minus 4. We get the second mark for simplifying and saying that x squared take away 2x plus 1 is equal to 0. We get the third mark for factorising and for saying that x minus 1 all squared is equal to 0, and therefore x must only be equal to 1. And we get the fourth and final mark for concluding that there is only one value of x, and so C and L have exactly 1 point in common, allowing us to achieve the full 4 marks needed in this question. In this question, we're told that x is directly proportional to the square of y, and y is directly proportional to the cube of z. We're also told that z is equal to 2 when x is equal to 32, and we need to find a formula for x in terms of z. Now if x is directly proportional to the square of y, we can say that x is equal to some constants multiplied by the square of y. And so we can say that x is equal to a y squared, where we can see that x is equal to some constant, which we're going to call a, multiplied by the square of y, y squared. So that's equation 1. Now we can then have equation 2, explaining how y is directly proportional to the cube of z, and we can do the same thing here. If y is directly proportional to the cube of z, we can say that y is equal to some other constant multiplied by the cube of z, and so y is equal to b z cubed. Now we're using a different constant, b, because the constant of proportionality for both equations won't necessarily be the same. And so we have two unknowns, a and b, but we'll be able to cancel them out soon. We now have our two equations, x is equal to ay squared, and y is equal to bz cubed. Now to find a formula for x in terms of z, we want to make x a subject and we want to get rid of the y's. Now how can we get rid of the y's? Well, we can substitute the values of y into the new equation. And so if x is equal to ay squared, and we know that y is equal to bz cubed, we can get rid of y by placing the value of y inside the formula for x. X is equal to ay squared. And so we already know the value of y, which is bz cubed, but we can say that y squared would be equal to this whole thing squared, which is equal to bz cubed all squared, and using our index laws, bz cubed all squared would be equal to b squared, and then z cubed all squared, and the second index law that we're going to use is that z to the power of 3 all to the power of 2 is equal to z to the power of 3 times 2, which is z to the power of 6. And so we can say that y squared is equal to b squared z to the power of 6. We can now substitute this in to equation 1. If x is equal to a y squared, and y squared is equal to b squared z to the power of 6, we can say that x is equal to a b squared z to the power of 6. But now we still have these two unknowns, a and b, and we want to get rid of them, because we just want a formula for x in terms of z. And so we're going to use the fact that z is equal to 2 when x is equal to 32. So we know that x is 32, a, b squared stay the same, and z is equal to 2, so we have 2 to the power of 6. Now we know that 2 to the power of 6 is equal to 64, and so 32 is equal to ab squared multiplied by 64. Now it's easy to get confused here and to think, well, we have two unknowns, what's the value of a and what's the value of b? But now we're just interested in finding the constant of proportionality between x and z. And so ab squared is a times b times b. But since a and b are both constants anyway, this entire thing can be merged into a constant of its own, and so we can just call it a different constant. We want to find this constant in order to find a formula for x in terms of z. And so if we know that 32 is equal to ab squared multiplied by 64, we can say that ab squared is equal to 32 divided by 64, which is equal to 1/2. And so bringing it back to this equation here, where we said that x equals ab squared z to the power of 6, we now know that ab squared is equal to 1/2. And so we can say that x is equal to 1/2 multiplied by z to the power of 6, which is our final answer, because we've now found a formula for x in terms of z. So we can say that x is equal to 1/2 z to the power of 6. Now this question is worth 4 marks. We get our first mark for setting up our two equations, x is equal to ay squared and y is equal to bz cubed. We get the second mark for eliminating y by finding the value of y squared and substituting this in to our first equation. We get the third mark for using the fact that x is equal to 32 and z is equal to 2 in order to find the constant proportionality between x and z. And we get the fourth and final mark for finding that this constant is equal to 1/2, and so we can therefore say that x is equal to 1/2 multiplied by z to the power of 6, allowing us to get the full 4 marks needed in this question. In this question, we're told that OABC is a trapezium. We're given the vector OA, which is equal to A, the vector AB, which is equal to B, and the vector OC, which is equal to 3B. We know that D is a point on OB, such that the ratio OD to DB is equal to 2 to 3, and E is a point on BC, such that the ratio BE to EC is equal to 1 to 4. We need to find the vector DE in terms of A and B, giving our answer in its simplest form. Now we have quite a complicated looking diagram over here, and so we can separate these into a bunch of different triangles, which will help us to find the vector DE in terms of A and B. Let's start with our triangle OAB. We know that the vector OA is equal to A, and the vector AB is equal to B. We can start by finding the vector OB. And now we know that to get from O to B, we can go from O to A, and then A to B. And so the vector OB would be equal to vector OA plus the vector AB, which in this case would be equal to A plus B. But now we're told that D is a point on OB, such that the ratio OD to DB is equal to 2 to 3. Now this has a total of 5 parts, And so the length OD has 2 of these 5 parts, and the length DB has 3 of these 5 parts. So we can therefore say that the vector OD is 2 out of 5 of the vector OB, and the vector DB is 3 out of 5 of the vector OB. Now let's move on to our next triangle, triangle OBC. We want to find the vector BC, and to find the vector BC, we can go from B to O, and then O to C. Now, we know the vector OB because we found in our first triangle that the vector OB is equal to A plus B. And so the vector BO is the same vector but in the opposite direction, and so BO would be the negative of OB. If we know that OB is equal to A plus B, the vector BO would be minus brackets A plus B. We also know the vector OC because we're told in our question that the vector OC is equal to 3B. And so BO plus OC is equal to minus brackets A plus B plus 3B, and simplifying, minus brackets A plus B becomes minus A minus B, add the 3B, and we're left with minus A plus 2B. And so we found that the vector BC is minus A plus 2B. But now we're told that E is a point on BC such that the ratio BE to EC is 1 to 4. And just like before, we have 5 parts. BE has 1 of these 5 parts, and EC has 4 of these 5 parts. And so we can say that the vector BE is 1 out of 5 of the vector BC. And we can say that the vector EC is 4 out of 5 of the vector BC. And so we're now left with our final triangle, where we can find the vector DE, which is what the question is asking us to find. Using this triangle, we can see that the vector DE is equivalent to the vector DB plus the vector BE. Now we said that the vector DB is 3/5 of the vector OB, and we said that the vector BE is 1/5 of the vector BC. Let's start with the vector DB. DB is 3/5 of the vector OB, which we found in our first triangle. OB is equal to A plus B, and so DB is 3/5 multiplied by A plus B, which will leave us with 3 out of 5A plus 3 out of 5B. And we can do the same thing for BE. We said that the vector BE is 1/5 of the vector BC, and we know that BC is equal to minus A plus 2B, and so 1/5 multiplied by minus A plus 2B will leave us with the vector BE, which is equal to minus 1 over 5A plus 2 out of 5B. Now we know that DE is equal to DB plus BE, and so we'd do 3 out of 5A plus 3 out of 5B plus minus 1 out of 5A plus 2 out of 5B. And so when we simplify this, we'll end up with the vector DE, which is equal to 2 out of 5A plus B. Now this question is worth 4 marks. We get the first mark for finding the vector OB, and for also finding that OD is 2/5 of OB, and DB is 3/5 of OB. We get the second mark for finding the vector BC, and for also finding that BE is 1/5 of BC, and the vector EC is 4/5 of BC. We get the third mark for using these ratios in order to find that the vector DE is DB plus BE. And we get the fourth and final mark for correctly simplifying and getting a correct answer that the vector DE is equal to 2 out of 5A plus B, allowing us to get the full 4 marks needed in this question. In this question, we're told that at the start of year n, the number of animals in a population is Pn. At the start of the following year, the number of animals in the population is Pn plus 1, where Pn plus 1 is equal to some constant k multiplied by Pn. At the start of 2017, the number of animals in the population was 4,000. And at the start of 2019, the number of animals in the population was 3,610. We need to find the value of this constant k. What we know so far is that Pn plus 1 is equal to k Pn. And we can substitute our values in for 2 different occasions. We can do 2017 to 2018, and then 2018 to 2019. Now remember that n refers to the year, and so Pn plus 1 between 2017 and 2018 would be the population in 2018. And that's equal to some constant k multiplied by the population in 2017. We know that the population in 2017 was 4,000, and so we can say that P 2018 is equal to k multiplied by 4,000. Now we don't know the value of the population in 2018, but we're going to have the same unknown when we do the same for 2018 to 2019. And so let's do that here. P 2019 is equal to K multiplied by P 2018. The population in 2019, we know, was 3,610, and so we can say that 3,610 is equal to K P 2018. Now in both equations, we have the population in 2018, which we don't know, and so we can get rid of it by substituting in the population in 2018. For example, by making population 2018 subject on this side, we can say that the population in 2018 was 3,610 divided by K. And so, we have two equations here. Population 2018 was 4,000K, and the population 2018 was 3,610 divided by K. Now, these populations are equal, because the population in 2018 would be the same regardless of which formula it's in. And so we can say that 4,000K is equal to 3,610 divided by K. Let's multiply both sides by K, and we'll end up with 4,000K squared is equal to 3,610. K squared is equal to 3,610 divided by 4,000, and therefore we can say that K is equal to the square root of 3,610 divided by 4,000. And when we substitute this into our calculator, we'll find that K is exactly equal to 0.95. And so we've now found that the value of the constant K is equal to 0.95. Next question is worth 3 marks. We get the first mark for setting up the two equations. P 2018 is equal to 4,000K, and P 2018 is equal to 3,610 divided by K. We get the second mark for setting these equations equal to one another by saying that 4,000K squared is equal to 3,610. And we get the third and final mark for continuing to rearrange until we find that the value of K is equal to 0.95, allowing us to achieve the full 3 marks needed in this question. In this question, we're told that Pat throws a fair coin n times, and we need to find an expression in terms of n for the probability that Pat gets at least one head and at least one tail. Now let's try to understand this question a little bit more. What does it mean to get at least one head and at least one tail? Well, the fact is that it's almost certain that Pat will get at least one head and at least one tail on each go. And so really, the only time that's not possible would be if he gets all heads or all tails. In any other situation, he'd have at least one of each. And so like we said, the only time that it's not possible to get at least one head and at least one tail is if he throws all heads or all tails. And so to go about this question then, we can find the probability of finding all heads or all tails, and then find the probability of this not happening. And so let's start by finding the probability of getting all heads. Now remember that this is a fair coin, and so the probability of getting one head is equal to 1/2. But now the probability of getting a head n times would be 1/2 to the power of n. And we can do the same thing for tails. The probability of getting a tail is 1/2, but the probability of getting a tail all n times would be equal to 1/2 to the power of n. Now we want to find the probability of getting all heads or all tails. And now in general in probability, when we have an or, we want to add the probabilities, and so the probabilities of all heads or all tails would be the probability of getting all heads add the probability of getting all tails, which we can see is 1/2 to the power of n plus 1/2 to the power of n. And so now we want to find the probability of getting at least one head and at least one tail. And so to find the probability of getting at least one head and at least one tail, you do 1 take away the probability of getting all heads or all tails. And now the reason we take this away from 1 is because we're trying to find the probability of not getting all heads or all tails, and all probabilities add up to 1. And so to find the probability of at least one head and at least one tail, you do 1 take away 1/2 to the power of n plus 1/2 to the power of n. And when we simplify this, this ends up being 1 take away 1/2 to the power of n, take away 1/2 to the power of n. And so we've therefore found an expression in terms of n for the probability that Pat gets at least one head and at least one tail. This question is worth 2 marks. We get the first mark for finding the probability of getting all heads or all tails which is equal to 1/2 to the power of n plus 1/2 to the power of n. And we get the second and final mark for saying that the probability, therefore, of getting at least one head and at least one tail would be 1 take away the probability of getting all heads or all tails, which is equal to 1 take away 1/2 to the power of n, take away 1/2 to the power of n, allowing us to get the 2 marks needed in this question. In this question, we're given a speed time graph showing the speed in meters per second of an object t seconds after it started to move from rest. In part A, we need to use 3 trapeziums of equal width in order to work out an estimate for the area under the graph between t equals 1 and t equals 4. Well, let's start by finding the points in which we're going to be finding the area. T equals 1 is over here, where the purple line is, and t equals 4 is right here. And so we're going to be finding the area enclosed between the space, between the 2 purple lines. Now we need to use 3 trapeziums of equal width, and so you can see that we can split our area into 3 different trapeziums. And so let's label this trapezium 1, trapezium 2, and trapezium 3. Now we need to know the formula for the area of a trapezium before we can continue with this question. And so the area of a trapezium is given by the formula a plus b over 2 multiplied by the heights. And so let's find the area of each trapezium. Trapezium 1, the area would be equal to a plus b over 2 times the height. Now in these trapeziums, a and b would be the 2 purple lines on each side of the trapezium, because you can see that they're the 2 parallel sides. And now the height will be the same for each of the trapeziums, which will be equal to 1 second. And so a plus b over 2 times height for trapezium 1 would be 4 plus 6 over 2 multiplied by the height of 1, and we got the 4 and 6 from the heights of these parallel lines, 4 and 6. And so for trapezium 1, the area would be equal to 5. Now we can do the same thing for trapezium 2. The area would be equal to a plus b over 2 times height. A is equal to 6, and b is equal to 7.2. And so we can say that the area is 6 plus 7.2 divided by 2 multiplied by 1, which is equal to 6.6. And finally for trapezium 3, the area would be equal to 7.2 plus 7.8 as a and b, so 7.2 plus 7.8 divided by 2 multiplied by the height of 1, which is equal to 7.5. And so using these areas, we can find the total area by adding the area of each trapezium. And so the total area would be equal to 5 plus 6.6 plus 7.5, which is equal to 19.1. And so we've now found that the total area under the graph between t equals 1 and t equals 4 is equal to 19.1. Now in part B, we're asked to find out what this represents. Now when we find the area of a graph, we're essentially multiplying the y-axis by the x-axis. And so let's think about the quantities that we have on y and x. The y-axis is the speed, and the x-axis is the time. And so the area is essentially equal to the speed multiplied by the time. We know that the speed multiplied by the time is equal to the distance, and so we know that the area would be equal to the distance travelled by the objects. Now this question is worth 4 marks. We get the first mark for splitting our area into 3 trapeziums of equal width, and for knowing that to find the area of a trapezium, we need to use a plus b over 2 multiplied by the heights. We get the second mark for finding the area of each trapezium and adding them together in order to find the total area. And we get the third and final mark in part A for getting the correct final answer that the area under the graph is equal to 19.1. We then get the fourth and final mark in part B for correctly saying that the area under the graph represents the distance travelled by the objects, allowing us to achieve the full 4 marks needed in this question. In this question, we need to show that 6x cubed over 9x squared minus 144 divided by 2x to the power of 4 over 3 brackets x minus 4 can be written in the form 1 over x multiplied by x plus r, where r is an integer. We'll start by getting rid of the divided sign, and so to do that, we can change the divide sign into a multiplication sign and flip the fraction on the right hand side. So we'll end up with 6x cubed over 9x squared minus 144 multiplied by 3 brackets x minus 4 over 2x to the power of 4. Now before we multiply across, let's see if we can do any factorising. We know something called difference of two squares, and we can identify that 9x squared minus 144 is a difference of two squares. And so when we factorise, we'll end up with 6x cubed over 3x plus 12 multiplied by 3x minus 12. And so we can see that that's the factorised form of 9x squared minus 144. And then we have the fraction on the right hand side, which is 3 brackets x minus 4 over 2x to the power of 4. Now when we multiply out, we'll end up with 6x cubed multiplied by 3 multiplied by x minus 4, all divided by 3x plus 12, 3x minus 12, and 2x to the power of 4. Now let's look at 3 multiplied by x minus 4, and we can expand that expression to end up with 3x minus 12. And then we have the same denominator as before. So immediately we can see that the 3x minus 12 on the numerator and the denominator can cancel out, which will leave us with 6x cubed on the numerator, and then 3x plus 12, and then 2x to the power of 4. We can get rid of the 2 in the denominator by dividing by 2 on both the numerator and the denominator. And so you can see that when you divide by 2 on the numerator, you'll end up with 3. And so by dividing both sides by 2, we're going to end up with 3x cubed divided by 3x plus 12 multiplied by x to the power of 4. Now we can get rid of the x cubed at the top. And so the x cubed will disappear on the numerator and we'll be left with an x in the denominator. So this now becomes 3 over 3x plus 12 multiplied by x. But now we want this in the form 1 over x, x plus r. So we need 1 in the numerator. Now we can get 1 in the numerator by dividing the numerator and the denominator by 3. Well, how can we divide the denominator by 3? Well, we can factorise 3 out of 3x plus 12. So let's see what we mean. We'll end up with 3 divided by 3 multiplied by x plus 4, all multiplied by x. And so you can see that the 3 multiplied by x plus 4 is equivalent to 3x plus 12. Well, now the 3's cancel out, and we'll end up with 1 over x plus 4 multiplied by x, and to write this in the format 1 over x multiplied by x plus r, we can say that this is equivalent to 1 over x multiplied by x plus 4. And so we've written this in the form 1 over x, x plus r, where r is equal to 4. Now this question is worth 3 marks. Now we get the first mark for inverting the fraction on the right hand side and changing the divide sign into a multiplication sign. We get the second mark for recognising the difference of two squares and for converting 9x squared minus 144 into 3x plus 12 multiplied by 3x minus 12. And we get a third mark for continuing to factorise and cancel out until we ended up with the final answer of 1 over x multiplied by x plus 4, allowing us to get the full 3 marks needed in this question. In this question, we're told that ABC is a triangle, and that D is the point on line BC, such that the angle BAD is equal to the angle DAC, which is equal to x, and we can see that on our diagram. We need to prove that AB over BD is equal to AC over DC. And so we can focus on each triangle separately. We have triangle ABD and triangle ACD. Let's start by using the sine rule for triangle ABD. Now we know that the sine rule states that sine A over A is equal to sine B over B, which is equal to sine C over C. We can apply this to triangle ABD by saying that sine X over BD is equal to sine ADB over AB, and we can label in angle ADB to make it clearer. And so we can say that sine X over BD is equal to sine ADB over AB. Now we want to find AB over DB, and so we can cross multiply as our first step, and we end up with AB sine X is equal to BD sine ADB. Now to get AB over BD, we can divide both sides by BD and then divide both sides by sine X, which will leave us with AB over BD is equal to sine ADB divided by sine x. And so we have an expression for AB over BD. And so let's see if we can apply the same logic to triangle ACD. Again, we can use the sine rule. Using the sine rule, we can say that sine x over DC is equal to sine ADC over AC. And let's label in angle ADC. And so sine x over DC is equal to sine ADC over AC. And doing the same thing as before, we can cross multiply to find AC sine x is equal to DC sine ADC. And to get AC over DC, we can divide both sides by DC and then divide both sides by sine x, which will leave us with AC over DC is equal to sine ADC over sine x. And so we now have an expression for AB over BD and AC over DC, and we need to prove that they're equal. AB over BD is sine ADB over sine x, and AC over DC is sine ADC over sine x. And so given that these two must be equal, it's reasonable to assume that we need to prove that sine ADB is equal to sine ADC. And so let's go back to our diagram. We can get rid of the labels for ADB and ADC. And let's just say that angle ADB is equal to y. Now we know that angles on a straight line add up to 180 degrees. Angle ADB and angle ADC lie on a straight line, and so we can say that angle ADC, this angle right here, must be 180 take away y. Because these two angles must add up to 180 degrees. And so let's show this in our expressions. We can say that AB over BD is equal to sine ADB over x, but we said that angle ADB is equal to y. And so this becomes sine y over sine x. We can do the same for AC over DC. We have angle ADC, but we said that angle ADC is equal to 180 take away y. And so we can say that sine ADC is sine 180 take away y, and then we have the same denominator of sine x. And so we have two expressions for AB over BD and AC over DC. And so we need to show that these two expressions are equal. And now one thing that we know from our trigonometric graphs is that sine y is equivalent to sine 180 take away y. And so now this becomes very helpful in proving that AB over BD is equal to AC over DC. So let's rewrite our expressions. We have AB over BD, which we know is equal to sine y over sine x. And so we can leave that how it is. Then we have AC over DC, which we said is equal to sine 180 take away y over sine x. But we now know that sine 180 take away y is equivalent to sine y. And so AC over DC is the same as sine y over sine x. And so if AB over BD is sine y over sine x, and AC over DC is sine y over sine x, we've now correctly proven that AB over BD is equivalent to AC over DC. Now this question is worth 4 marks. We get the first mark for using the sine rule for triangle ABD. We get the second mark for using the sine rule for triangle ACD. We get the third mark for acknowledging that sine y is equivalent to sine 180 take away y. And we get the fourth and final mark for using this fact in order to prove that AB over BD is equal to sine y over sine x, and AC over DC is sine y over sine x, and therefore AB over BD is equal to AC over DC, allowing us to get the full 4 marks needed in this question.